is going to give me my pulse duration. Right? Ooh? So
that would be 4.
We're gonna come to it. I have a great example of I may not even get to spatial pulse, which is fine. We got 3 lectures on this. Next chapter, intensity. It's not so much information, but I got a great example of. We're gonna demonstrate in 1 second when we get to the next page. Okay. Pulse duration is determined by the source, meaning the manufacturer determines the time that these pulses are going to last. We can't change that. Okay, we can't change the length of the pulse. I'm sorry, the time it takes to create the time of the pulse from beginning to end. We can't change that. Okay, that's determined by the manufacturer when they create these transducers. Okay, the only way you can think about changing that would be to change the transducer, right? Because maybe a different transducer has a different pulse duration. But there's no button on the machine that lets us change the length of time that a pulse can be created. Okay, so it's determined by the sound source, all right, meaning the ultrasound system or the transducer itself. The manufacturer, that when they make it, they determine the pulse duration. All right, it is not adjustable. It is fixed for that specific transducer. Like I just said, the only way I can even think about wanting to affect my pulse duration would be changing my transducer. Okay, there's no button for that. No button for that. Okay, there's no knob for that. There's no lever for that. We go. Sweet. All right. Example right here, guys. Pulse duration, guys. You see, pulse duration is only during talking time. Only during the talking time. The listening time is not considered pulse duration. Remember, pulse duration is the time from the beginning of the pulse to the end of the pulse. How many cycles are in this pulse right here?
4.
Yeah. You can count 4, easy. Or sometimes people just count the humps. 1, 2, 3, 4. You know, but you got to be careful about that depending on where it starts at. Okay. So when I count, I always start from the beginning.
From the line.
1 pulse, 2 pulse, 3 pulse, 4. I'm sorry, cycles. Apologize. 4 cycles in this pulse. That's my example right there, guys. Dewey, man, guys, Dewey works hard for the class. He's making examples for us. He actually has, like, he made it. I'm going to have to incorporate where he has like the little ball moving, counting the cycles. Dude is amazing with the PowerPoint. You know, so he's collabing with me, you know, to help me make these presentations better. So appreciate you, dude.
Thanks, Dewey.
Thanks, Dewey.
That's why you got that
You're the
copy.
best.
Thanks.
Okay. So pulse duration is equal. Again, I already told you this, guys. It's equal to the number of cycles in the pulse multiplied by the period of each cycle. The period. The time. Hold on. Stay at the top. Stay at the top. Stay at the top. Stay at the top. Again, pulse duration equals the number of cycles in the pulse multiplied by the period.
Period means you're talking about the time.
Period.
The time it takes to complete 1 cycle.
Yes.
So it's 4 cycles right here. Whatever that period is, let's say our period is 0.5. Therefore, our pulse duration 4 times 0.5, right, is going to be what? 2, right? Don't that fall within diagnostic range?
4 times 0.5.
Okay. That's why I say the numbers. If you think that's why pulse duration is a longer time than the actual period. But you can figure out the pulse duration if you know the number of cycles and you know how long it takes to complete each cycle, which is the period. All right. All right. When? All right. So pulse duration, guys. Pulse duration is directly proportional to the number of cycles, right? If I increase the number of cycles, the time it takes to create that pulse is going to increase, right? So it's also proportional to the period. if each cycle takes a longer time to be produced, that's also going to increase my pulse duration, the time of that pulse. Right? So, let me draw an example up here, right here, guys. So, if I have, okay. Those have the exact same. This is how many cycles? How many cycles are in these pulses? 3 cycles in both of these pulses, right? Which one is going to have a longer pulse duration?
The top one.
The top one, right? Because the time, I'm just saying, if this was 1 second, let's say this is 1 second right here. If it comes to something like this, guys, I'm always going to give you the time, just like I did on the test. I'm always going to tell you how much time if I'm asking you for a specific number, right? Because I have to give you something so you can figure it out, all right? So because, remember, this period is going to take a lot longer. We know that because how long these wavelengths are, right? Period and wavelength, they kind of go in the same direction, right? If the wavelength is long, then the time it takes to create that one cycle is going to be long as well. Okay? So you can eyeball this and see that this pulse right here is going to have a longer pulse duration than this pulse. So it's kind of safe to say that if the frequency is high, the pulse duration is going to be shorter, right? Right. So again, pulse duration is directly proportional to the number of cycles and the period. All right, and the period. If you increase the time it takes time to complete one cycle, then you're automatically going to increase the pulse duration. The time to create that pulse, meaning that the pulses they're not gonna be most of when ultrasound are created, they're not gonna make the pulse. It's not gonna be like this. The amount of time is gonna be the same for each cycle. Okay, ultrasound transducers don't produce pulses with varying frequencies within that one pulse. Okay, they're gonna be the same. Right? So it's safe to say that if I increase the time it takes to create one cycle, I'm going to increase the pulse duration as well. If like the second one, if I decrease the time or decrease the time of each cycle, then my pulse duration is going to be a lot shorter. Okay?
But the frequency is the number of the cycle within the specific time. Yeah, specific time. Yeah. So cycles. He said the pulse duration, it's cycle over the frequency.
I haven't even got there yet, Sophie. I'm coming there.
Yeah, because I'm seeing the versibility.
Yeah, I mean it makes sense, right? Just think, aren't period and frequency inversely related?
Yeah, exactly.
Right? So of course, that's what I just said. If the frequency is high, then my pulse duration is going to be short. If the look at number 1. That's a low frequency compared to number 2, right?
Yeah.
Right. So they're going to be inversely related. So my longer pulse duration, you see, that's going to be a lower frequency. The events aren't happening as often. Or if I have a high frequency transducer number 2, then look how short my pulse duration is. That's why they're inversely proportional, inversely related. Right? And then you already know how it's related to period, so automatically it's going to be inversely related to the frequency. That's why I say, guys, building blocks, because you have to know this to know that. You know, you have to know the beginning to know where we're going. I'm sorry, I didn't even put my hand up. All right? So, to figure out pulse duration is equal to the number of cycles divided by the frequency. Guys, I have a great example. Let's get down on this board. I can delete. Y'all can erase this?
Yeah. Oh, what? Hold on.
So these two equations you would use depending on the information you have?
Absolutely. It depends on the information given. But both of these are formulas to figure out the pulse duration. You're always going to have to know the number of cycles regardless. You know, but you can also figure it out either way because, and the way we can figure it out is because we know that period and frequency are reciprocals. Okay? You good, dude?
Yes, sir.
And as we started, so I got time. Huh? If I want you to. If I want you to. And I'm feeling great today. I'm, you know, like, you can't let the little minute stuff get you down. All right. So, PD equals number of cycles times period, or PD equals number of cycles over frequency. Or hertz. Absolutely. All right. So let's say, for instance, guys, just give me a number. How many cycles y'all want? 4, 3, 3 cycles. You know, that's how many are in this pulse, right? All right. So let's say our transducer frequency is 2. Okay. So let's do this. That's cycles. 2 is our megahertz. So this answer right here, the number of cycles, 3 over 2, right? 3 over 2. That equals what, guys?
Is that hertz? You have to convert to hertz?
Pulse durations.
I'm sorry, what you say?
Because you say frequency, the formula is frequency, the hertz or megahertz. You want to-
Frequency, hertz is the unit for frequency.
Okay, so we're gonna convert to hertz or it's
We're just gonna deal with the numbers because we're looking for pulse duration. We automatically know that's gonna be in microseconds. That's just a random number I threw out for a transducer frequency. We can use 5. Whatever number you guys want to use, we can do it 2 times just to show you how this works. Okay, so 3 over 2 equals what?
1.5.
1.5, right? Equals 1.5. That's gonna be our pulse duration. Okay? Yeah, microseconds. Alright, so for us to figure out, let's figure out with the numbers we have right here, what is the reciprocal of 1.5?
2.2 over 3.
Reciprocal of 1.5.
It's gonna be 1.
0.33.
Our transducer 2 megahertz. I'm sorry. I don't want the reciprocal of the 1.5. I need the reciprocal of the megahertz. 1 over 2, right? 1 over 2, right? The reciprocal of the megahertz will be 1 over 2. So that's our period, correct? 1 over 2. So what is the number of cycles? It's 3 times 1 over 2 equals 1.5, right? Equals 1.5, right? Okay. 1.5 microseconds.
The period was the reciprocal of
The frequency. The period is the reciprocal of the frequency.
Yeah.
We're good, guys?
Yeah, yeah.
I-
that 1/2 represents the megahertz.
that 1/2, I'm taking the megahertz and I need to know what the trying to figure out what the period is. The period is the reciprocal of 2 because we know that it's 2 megahertz, right? The reciprocal of 2
Which is
would be
that's a
1 over 2.
So the 2 megahertz, that's the frequency.
That's the frequency.
Yeah, so you get it.
So the inverse of that, or the reciprocal of the megahertz, would give us the period, which is 1 over 2, correct? So the number of cycles times the period equals 1.5, just like the number of cycles divided by the frequency equals 1.5. Okay? If our number of cycles is 3 and our number of megahertz is 2. I'll kind of make you guys a couple problems so we can work that out again. Okay? But any questions? Questions, guys? You want to work out another one? Are we good? Yeah? 5 what?
period.
All right, you have to put your calculator out to get these numbers.
Yeah.
5 cycles.
يعني ليش حولها؟
5 cycles. How many megahertz? That you about to work it out. Give me a number. 3? 3. 3. Alright. I'm just gonna, you guys have this? I can erase this?
بنحط رقم الفيديو بنحطها سلاش.
I just find it easier. Like I can, of course, I can just, if I know the megahertz, I can just figure out the period just based on that, right? The period is 1/3, right? Okay. So if we want to, because I worked last time I worked it out, I did this one first. I did the second formula first. But we can, if we know the megahertz, then I can still do the first one. So we have 5 cycles times the reciprocal of 3 is what? 1/3. 1.6? I don't have my calculator. 1.6. I'm trusting you for an answer. 1.6. So like 1.67 maybe. 1.67. So let's take our 5 over the number of megahertz. 3. What's that? 5 divided by 3? 1.6. Of course, right? Y'all already gave me one, so I automatically knew what that was. Okay? So that's how we're figuring out the time, the duration of our pulse. The time it takes from the beginning to the end of the pulse. Right there, with both of those formulas right there. So you would have to have, I would have to give you the number of cycles and or the number of hertz. Okay? If you guys need me to, I can make you guys a couple problems doing the same thing with just random numbers, big numbers. But again, this is like a double layered question because you have to understand the relationship between period and frequency. This one.